we're going to look at how to find the inverse of some trig functions. So if I give you f of x equals 2 sine 4 theta minus 1. Okay. I'm going to first start by switching x and y. Now x in this case is theta. Remember, theta just represents the angle. It's functions like x. I could have put an x there if I wanted to. Oh, this, if I'm going to, let's not mix signals. This is going to be f of theta. Okay. I could have also just written this as y. You'll probably more likely encounter this just as a y. So if you see it this way or just y, we're going to switch x and y. So I'm going to write theta equals 2 sine 4y minus 1. Okay? So I want the sine by itself. Now remember that this is inside the sine. It doesn't have to have parentheses around it when you're just having something multiplied by the y. If I wanted to add something inside of the sine with the y, I would have to have the parentheses there. So I know that this one is outside the parentheses, so I'm going to add 1. So I have theta plus 1 equals 2 sine 4y. So I'm going to undo multiplying by 2 by dividing by 2. So now I have theta plus 1 over 2 equals the sine of 4y. And you can put your parentheses or not put your parentheses. Now, to undo sine, we take the inverse sine. So if we take the inverse sine of both sides, the inverse sine of the sine just leaves you with 4y. And on this side, if I take the inverse sine on this side, I have to take the inverse sine on the left side as well. So I'm going to have the inverse sine of theta plus 1 divided by 2. Now that equals 4y, so to get the y by itself, I'm going to divide by 4. Now, on this side, if I have this whole thing and I put divide by 4 like this, it looks kind of messy. So what I'm going to choose to do instead is, remember, dividing by 4 is really the same thing as timesing by a fourth. So I'm going to choose to write it as 1/4 inverse sine of theta plus 1 over 2. And then we're going to say that equals f inverse of theta. Okay? And that's how you can find the inverse. So let's try another example. Let's have y equals -3 cosine of 4 theta minus pi halves, like that. Okay. So I'm going to switch x and y. In this case, x is theta, so I'm going to have theta equals. This time we had a y, so I'm going to have just -3 cosine of 4 y minus pi halves. Okay. Now, in this case, because we have the parentheses, I know that pi halves is inside the cosine. So the only thing outside the cosine is the -3. So I want to undo multiplying by -3, so I'm going to divide by -3. So when I divide by -3, I have cosine of 4y minus pi halves. Okay. So to undo the cosine, I'm going to take the inverse cosine of both sides. Well, if I take the inverse cosine of the cosine, I'm left with just this part. And if I take the inverse cosine of the left side, I just keep it as the inverse cosine of theta over -3 equals 4y minus pi halves. So I'm going to add pi halves. So notice the pi halves will be outside of the inverse cosine. So I'm going to have the inverse cosine of theta over -3 plus pi halves equals 4y. So I want to undo multiplying by 4. Once again, if I do divide by 4 here and then divide by 4 here, this looks really not so great. So what I'm going to choose to do instead is multiply this whole thing by a fourth. Now, let's not lose that 3. I have to distribute the 1/4 to both the inverse cosine and to the pi halves. So I'm going to have 1/4 inverse cosine of theta over -3 plus, remember to multiply fractions, you do top times top, so pi, and then bottom times bottom, so 4 times 2 gives us 8, equals y. Okay? Now, because I started with y and this was not written in function notation, I don't need to change this to f inverse of x. Okay? So let's try another one. Okay, if I have y equals 2 tangent 1/2 theta. Okay. I'm going to start by switching x and y. So I have, oh, let's do this one as x since I haven't done an x yet. Okay. So let's switch x and y. So I have x equals 2 tangent 1/2 y. So I need to get rid of the timesing by 2 that's out in front. So I'm going to divide by 2. So when I divide by 2, I end up with x over 2 equals tangent of 1/2 y. Okay. So to undo the tangent, I'm going to take the inverse tangent. Okay. The inverse tangent of the tangent just gives us 1/2 y. And if I take the inverse tangent of the left-hand or the right-hand side, I have to take it of the left-hand side. So then I get the inverse tangent of x over 2 equals 1/2 y. Well, to undo multiplying by the 1/2, I'm going to divide by a half. But remember, dividing by a half is the same thing as multiplying by 2. So I end up with 2 inverse tangent of x over 2 equals y. Now, notice again, we started with a y, so because I started with a y, I can end with a y. If I had started with like f of x here, then I would need to write this as f inverse of x. And that's how you find the inverse of tangent, or of trig functions.